All right, let's talk about the secret social life of your software. Now, I don't mean after-work drinks. I mean how the different pieces of your code, your objects, your structs, actually talk to each other. We're about to take a deep dive into making that communication clean, organized, and powerful.
So I want you to think about one of your Go projects for a second. How do all those structs and components coordinate? Is it a clean, well-defined system? Or is it more like a chaotic free-for-all where everything talks to everything else? That's what we call spaghetti code, and it's an absolute nightmare to debug and maintain. That's the exact problem we're here to solve today.
So here's our game plan. First, we'll get on the same page about what these behavioral patterns even are. Then, we're going to explore some amazing tools for handling requests, for simplifying communication, and for swapping out algorithms on the fly. And stick around to the end because I'm going to give you a cheat sheet to help you pick the perfect tool for the job.
Okay, let's start at the beginning. Understanding this one core idea is going to set the stage for everything else we talk about.
That sounds a little academic, right? So let's break it down. All this really means is that these are proven recipes for making your objects play nicely together. They're all about who should do what and how they should talk to each other. It's about turning that potential chaos into clean, predictable, and way less complex code.
Now, you might have seen some of these patterns in books or online, and maybe the examples were in Java or C++. Don't worry about that for a second. These ideas are totally universal. For us Go developers, they map so beautifully to the tools we use every day. When you hear component, just think struct. When you hear about an abstraction, think interface. We're just applying these powerful concepts using Go's simple and elegant toolkit.
All right, time to open up the toolbox. This first set of patterns is all about managing flow. We're talking about how tasks get passed around your system and how you can move through your data in a clean, consistent way.
The chain of responsibility pattern is awesome. It basically lets you send a request without needing to know who's actually going to handle it. You just pass your request to the beginning of a line, and it gets passed down from one handler to the next until someone in that chain says, "Yep, I can take care of this."
So in Go, what does this look like? Well, you'd probably define a handler interface, with maybe a handle request method and a set next method. Each struct that implements this interface checks the request. If it can't deal with it, it just calls next.handleRequest. But here's the pro tip. What if the request gets to the end of the chain and nobody handled it? You always have to think about having a default handler at the very end to catch these cases. Next up, the command pattern. This one is really cool. It takes a request or a task and turns it into a standalone object. So instead of just calling a function directly, you create, say, a createUserCommand struct. This object holds all the information needed to perform the action. And because it's an object, you can do some really powerful stuff with it, like put it in a queue, log it, or even save it to run later.
And this is where it gets really interesting. Yeah, I can add a little more code, a little boilerplate, but look at that pro column. Support for undo and redo. This is a huge deal. You can just add an unexecute method to your command object, and suddenly, implementing a complex undo feature becomes almost trivial. For senior engineers, that's a massive win.
And rounding out this section is the iterator. This pattern is all about giving you a consistent way to go through a collection of items. You don't care if it's a slice, a map, or some custom tree structure. You just want a next method that gives you the next item. Now in Go, a lot of the time we can get this behavior naturally with the range keyword and channels, which is great. But when you're building your own complex data structures, creating a custom iterator is the perfect way to hide that complexity.
Okay, on to our next batch of tools. This section is all about taming the beast of complexity. We're going to look at patterns that untangle messy communication webs and help you manage an object's history and state over time. Have you ever had a situation where a dozen different components all need to know about each other? It's a recipe for disaster. The mediator pattern solves this by introducing a central hub. Instead of talking to each other, all the components talk to the mediator, and the mediator coordinates everything. This makes your individual components way simpler because they don't have to know about anyone else. But, and this is a big but, especially for more experienced devs, you have to be careful. Look at that first con. The mediator can become a god object. If you're not disciplined, you can accidentally move all your application's logic into this one giant unmaintainable struct. The trick is to make sure the mediator is only responsible for communication, not for doing the actual work of the other components. The observer pattern is a true classic. You've definitely seen this before. It's basically a publish-subscribe system. You have one object, the subject, and a bunch of other objects, the observers. When the subject state changes, it automatically notifies all its observers. It's perfect for situations where a change in one part of your app needs to trigger updates all over the place. And in Go, channels are often a fantastic built-in way to implement this pattern.
Now this slide covers two really useful patterns for handling state. First, memento. Just think of it like creating a save file for an object. It lets you capture and store an object's internal state so you can restore it later. Perfect for implementing undo. The state pattern, on the other hand, is totally different. It lets an object change its behavior when its internal state changes. Instead of a huge if or switch statement, you encapsulate the logic for each state into its own type.
All right, let's get to our last group of patterns. This whole category is about one thing: flexibility. These are the tools you use when you want to make parts of your code's behavior dynamic and totally swappable.
The strategy pattern is easily one of my favorites, and it's so incredibly useful. It lets you define a family of algorithms, stick each one in its own object, and then make them completely interchangeable. Your main object doesn't care how something is done, it just delegates the task to whatever strategy object it's currently holding. This is the ultimate way to get rid of those massive, ugly if-else blocks that try to do 10 different things.
Now, it's easy to get strategy and template method mixed up, so let's be clear. While they both deal with algorithms, template method works a little differently. It defines the skeleton of an algorithm in a base type, but then it lets other types override certain specific steps. The overall process stays the same, but the details can be customized. In Go, you can pull this off really nicely using struct embedding.
The visitor pattern is a bit more advanced, but it's seriously powerful when you need it. It lets you add a new operation to a whole set of existing types without changing those types at all. You create a separate visitor struct that knows how to perform the new operation on each type. This is an incredible way to respect the open-closed principle. You can add new functionality just by creating a new visitor.
Whew! Okay, that was a lot of information, I know. So the big question is, how do you actually pick the right pattern for the problem you're facing right now? Let's boil it all down into a simple guide.
Think of this as your starting point. Don't try to memorize the patterns. Try to memorize the problems they solve. Are a bunch of your objects tangled up in a communication mess? Look at Mediator. Do you need a robust undo system? Command is your best friend. Is your code full of if statements that choose different ways of doing something? That is a textbook sign that you need the strategy pattern. Let the problem guide you to the solution.
And really, if you take one thing away today, let it be this. These patterns aren't just some abstract, theoretical stuff you read in a textbook. They are practical, battle-tested solutions to the real, everyday problems we all face as developers. Getting comfortable with these tools is what takes you from just writing code to truly architecting strong, flexible, and maintainable software.
So, I'll leave you with this challenge. Right now, think about the Go project you're working on. Where's the mess? Where does the communication feel tangled? Which part of that code could be dramatically simplified and improved by applying one of the patterns we've just talked about? Go find it.